Hey students, welcome. I am so glad that you have taken the time in your busy schedule to try this short little YouTube video that I have made to help you prepare for our test coming up on magnetism. This is going to be kind of a real simple task that I want you to do. I want you, in just a few minutes, there's going to be a slide that's going to have all the terms that you need to know for this week's test. When you get to that slide, I want you to pause it, stop the video, write all those down. And then as we go through here, I'm going to talk about some definitions, talk about some general concepts, and I'm hoping that you'll be able to recognize the vocabulary word that I'm talking about. I'll provide some additional information, and you know me, I'm not one that's prone to be brief. I like to talk. But hey, anyway, I am so glad again that you're making this effort. It says a lot about you. I hope you get some enjoyment out of this. I hope it helps you a lot with the test. And I hope that when I keep on posting these on YouTube, because this won't be the last one, and I promise you it will get better, I hope you come back. Again, thank you so much, and let's get started. Okay, this is what I was talking about. These are the terms that are going to be on this week's vocabulary test. Right now, stop this video, write down these terms, and then again, as I go through the concepts, look at one of these terms and see if you can figure out, without using your textbook, without using your notebook, which term we're talking about when I mention each definition. All right, let's get started here. Any material that attracts iron or some material that has iron in it. Okay, again, any material that attracts iron or some material that has iron in it. If you said magnet, awesome. You're off to a great start. This is the area of magnetic force around a magnet. Allows magnets to interact without even touching. If you've ever held two magnets in your hand, and especially if they were opposite poles, and you felt that attraction, that energy that pulled them together, or if you held were the same poles and you're trying to push them together and you feel something there, well, that's what we're talking about in regards to this vocabulary term. Okay, again, you might find it easier to stop or pause the video after I read the definition, because again, I might be coming back pretty quick with the answer. Well, the answer to the previous definition was magnetic field. On to the next one. Again, I hope you're sticking with me, and I hope you're getting something out of this. Okay, we have talked about these this entire school year. This is one of about 100 basic substances that make up all the things in the universe. If it is matter, if it has mass and takes up space, it is made up of one of these. I hope you said element, but I'm afraid that some of you might have said atoms. If you said atoms, you're not entirely wrong. You are right. It is atoms that come together to make molecules, that come together to make compounds, that come together to make you, me, the book, the computer screen you're looking at, and so forth. But the elements is a general term that we use for the things that come together to make matter. We say atoms are the smallest unit of an element. And again, we're going to go into this more detail before we begin studying for the CRCT. This is a particle in the nucleus of an atom that carries a positive charge. Again, got to remind you, the atom is broken up into three main parts. We need to know each of these three parts for the CRCT. This part lies in the nucleus, the center of the atom, and it has a positive charge. Again, try to remember in class, P for positive, P for whatever you think this term that I'm talking about. If you said proton, you are correct. Again, try to remember P for proton, P for positive charge, and remember the proton lies in the nucleus of the atom. Alright, the previous vocabulary word was proton. This one is also with the proton in the nucleus of the atom, but it has no charge. Again, let that no charge or neutral charge kind of provide you a good hint on what vocabulary term I'm talking about here. If you said neutron, you are correct. Outstanding. Oh, by the way, if you have listened up until this point and you have participated, I want you to know that you have earned extra credit for doing this. Please, when you next time you see me in class, mention not only the YouTube video, but mention the exact slide, this one, that the extra credit issue was brought up, and I'll give you some points. Good job. Alright, we're moving on. This vocabulary term refers to that particle that is a part of the atom, but it lies outside the nucleus. It has a negative charge, and we've talked about a lot in class. There are orbitals, and you can only fit some in the first orbital and some in the second and some in the third. But again, it's an extremely small particle, negative charge, orbits the nucleus, on the outside of the atom. Good luck. If you said the electron, you are correct. Again, there's really no way that I can, no really easy way I can tell you to remember this. You know, you have P for proton, P for positive, and N for neutron, and neutron is so similar to the words neutral and no charge, but you're just going to have to remember that electrons orbit the nucleus, and they have a negative charge. Good job. I've already mentioned this vocabulary term a few times tonight, especially when we're talking about the atom. This is the center region of the atom. You know, we had a few jokes a few weeks ago when a lot of people were referring to this as the brain of the atom, and I kind of corrected you and you know, in regards to there's really no brain inside an atom. But this is that center region in the atom. The proton and the neutron live here. Good luck. If you said the nucleus, you are correct. Again, the nucleus, the center of the atom. Let's not refer to it, at least in my class, let's not refer to it no longer as the brain of the atom, just that center region of the atom where the proton and neutron live. Wow, what a bad tattoo. Anyway, this is the smallest particle of an element. Smallest particle of an element. If you said atom, outstanding. Again, you're going to find that sometimes it's confusing to go between atom and element. Just remember that atom is the smallest unit of an element. If you had a handful of gold, then I would say that you had the gold element in your hand. But if you only had one gold atom, then that's when the term atom would come into the conversation instead of the word element. Anyway, great job. Okay, we are back to magnets. Okay, this term applies to one of two that every magnet has. Sometimes we label them north and south. If you said magnetic pole, great job. Remember, every magnet has two of these, a north and a south. We label the north one because if you allow the magnet to swing freely, like from a string hanging from the ceiling, over just a period of few moments, that magnet would eventually rotate itself to where one end, the north end, would be facing our Earth's north pole. Good job. This is the attraction or repulsion between magnetic poles. The attraction or repulsion between magnetic poles. If you said magnetic force, you are correct. This is a grouping of atoms that has their magnetic fields aligned. Again, this is a close-up view of what the atoms would look like inside either a magnet that has strong magnetism or one that has little to no magnetism. The answer, magnetic domain. Good job if you got it right. If you got it wrong, well, play it back, look back in your notes, review your flashcards, and just make sure you get it right when we take the test in class. Some magnets you can put in a drawer and come back 5 years later and they will be just as strong as the day you bought them. Okay, these are magnets that hold their magnetic properties over a very long time. If you said permanent magnet, you are correct. Good job. Hey, stick in there. We are almost finished. As you study more and more about magnets, you'll find that there are a lot of materials out there with varying degrees of iron that really make some very strong magnets. Again, this vocabulary term refers to just a general material that has strong magnetic properties. If you said ferromagnetic material, you are correct. Good job. Try to remember that ferro forms the Latin root word of ferrous, which is another way of saying iron. So again, these are materials that have just strong magnetic properties. Good job. Okay, some magnets are just no fun. As shortly after you make them, you begin to use them, and you find really quickly that they lose their magnetic properties very quickly. What do we call these types of magnets? If you said temporary magnets, you are correct. Good job. Okay, we are almost finished. This vocabulary term is the attraction or repulsion between magnets. If you said magnetic force, you are correct. I had you draw these in class. These are the invisible lines that map out the magnetic force field. If you said magnetic field lines, you are correct. Good job. Well, guys, that's the end of this study review. I hope you've got as much out of it as I have. Hope you've had a little bit of fun. And again, if you feel like you need to, go back and do it again. If not, I'll see you next time.